Aloha and welcome to this Terraformation presentation for the U.S. Forest Service. Today we'll be discussing seed supply, which is often overlooked as a bottleneck to restoration. Next. So my name is Emily Grave, and I am on the Forestry Partnerships team with Christian, who is with us today as well. And we are joined by our colleague, Dr. Marian Chau, who is head of seed banking at Terraformation. And we are both based in Hawaii on the island of Oahu, which is why we cannot join you in person today. Next. Okay, a bit about Terraformation. So Terraformation is a tech-accelerated forestry company, meaning that we accelerate forest restoration around the world to combat climate change. We are a team of subject matter experts who feel the best way to fight this existential threat is not necessarily with new technology, but with reliable tree planting methods that utilize technology in order to overcome bottlenecks and scale. Next. So we engage key stakeholders in priority regions globally. We identify and overcome bottlenecks with our solutions, and then we scale. In addition to the obvious benefits of forest restoration, like ecosystem services, beautification, wildlife habitat, and so on, there are also often co-benefits for the surrounding communities in which we work, like job creation, microgrids, and potentially access to fresh water. Next. So Terraformation is laser focused on native biodiversity restoration. We support ecologically adaptive native seed collection, growing, and planting in the right place, of course, right tree, right place. Since native forests can sequester up to 40 times more carbon than non-native forests or monotypic stands. Next. So what are some of these hurdles that our partners have faced? And we heard the same story from people on the ground, and then a lot of this was confirmed in a recent research study that we launched earlier this year. So overwhelmingly, number one was finance. The majority of respondents in our study said funding was an issue. Although the largest tree planting entities don't really have issues with funding, the smaller NGOs definitely do. Only a fraction of philanthropic dollars are going toward restoration activities. And the largest tree planting organizations, they're only planting a handful of species. And then seeds. So seed crop is seasonal, right? Sometimes you'll have a bad seed year due to drought, storm, or perhaps insects. In the context of climate change, these effects are exacerbated, right? With more storms, more fires, longer periods of drought. Some of these trees just aren't going to survive. And when that happens, we're going to lose that genetic diversity forever, leaving nothing for the next generation or our future. And Marian will explain a lot more on this, but restorationists often only collect enough for just that season. And that greatly limits their ability to scale, in addition to the future lack of diversity in stored seeds, which is why we build tools like seed banks to help overcome the dearth of native seeds globally. And then training on botany, ecology, horticulture, and more. As an example, biodiverse forests are the utmost goal of Terraformation, and diversity lends to resiliency, right? But sometimes this isn't common knowledge. So we provide the training and expertise to be successful no matter what the current level of understanding is. Next. And now Marian will tell you more about one of the most severe bottlenecks we incurred, seed supply.
Thanks so much, Emily. And yeah, as Emily just mentioned, seed supply is already a bottleneck for so many restoration projects. And if we want to scale that up and actually plant 1 trillion trees across the world, we'll need at least 3 trillion trees, or sorry, 3 trillion seeds, probably more. As Emily also brought up, we have natural disasters that are only becoming more severe and more frequent. And we've seen and heard from a lot of our partners that if there isn't a supply of native seeds on hand ready to go, often they just have to resort to revegetation with non-native seeds often. Seeds are also becoming harder and harder to collect, especially where ecosystems have already been destroyed or lost. But even in intact ecosystems, climate change effects on things like seasonality or plant phenology sometimes mean a year or even several years without good seed harvest. So all of these challenges can lead to decreases in biodiversity and in locally adapted genetic diversity that's so needed. And this can leave the ecosystem more vulnerable and even less resilient to these kinds of threats and other threats. Preservation seed banking is actually really well established. So this is one of those tried and true methods like Emily was mentioning. So there are decades of science backing it up. We know the methods really well. Most current seed banks do focus on longer term conservation, Some of the examples you're probably very familiar with would be like the Svalbard Global Seed Vault, which is for agricultural seeds only, the Millennium Seed Bank, which banks wild seeds, especially endemic and threatened species. And many folks in this audience might also be familiar with the USDA's National Laboratory for Genetic Resources Preservation in Fort Collins, which is one of the only large seed banks to support both conservation and restoration. And large seed banks like this, we're so grateful for the foundational work that they've done to establish seed banking as a proven method for preserving biodiversity. However, more seed banking capacity is still needed, especially for restoration. And so that's where we come in. What we work on at Terraformation, one of the things we work on is focusing on building capacity for restoration seed banking. So published research has shown that losses from the combination of suboptimal seed storage, losses in germination, and from the timing of use of seeds, these can all lead to up to 90% of seeds being wasted. And if we continue on that path, it will lead to unsustainable harvesting at the global level and often at the local level. But seed banking can help solve all of these challenges to avoid a lot of that waste. So if we were able to set up a hub and spoke network connecting the larger seed banks with smaller restoration seed banks, that could help us meet these large global goals for ecosystem restoration. The smaller seed banks can use low-cost methods to provide that steady supply of local seeds for restoration and be prepared for emergency response. At Terraformation, we wanted to answer this question: how many seed banks are needed and where do we need them? And as of this recording, we are in the process of releasing a white paper that looks at this question in detail from a global scale. Okay, so our first step in this study, we're calling this the Global Seed Bank Index. And our first step was to estimate the number of seed banks that are in the world currently. So to do this, we used 11 primary sources that included databases and existing kind of seed bank networks that we could easily access. We also did a little bit deeper internet searching, reaching out through our networks, and we excluded seed banks that store only agricultural crop seeds, as those would not be contributing to restoration, but mostly focusing on food security. But we did include seed banks of any size, storing seeds from any native species, and which used drying methods prior to storage. So if they did a mix of both native and crop species, we included them. And even if they, were longer term preservation seed banks for native species, we included them as having the potential to contribute to restoration, as long as they bank some native species. And in this map, you can see the darker colors indicate there are more seed banks within a country. And you can see that larger countries, just by nature of their size, and also Western European countries have more seed banks. And so that's either due to directly due to country size and or perhaps a longer history of seed banking in those regions. It might not surprise you to hear that the US has the most seed banks, as it has really been a growing movement in the US over the last decade or two, especially. But we can also see on the flip side that Africa and most of Latin America especially need more seed banks. So they're really underrepresented in those regions. And then we've also got the orange dots indicate the large seed banks, such as the lab at Fort Collins, which provides some of the kind of foundational knowledge um, for which all these other seed banks can build on. Okay, so our next step in this global seed bank index was to pair that country level seed bank data with country level estimates of restoration potential. And so the way we've defined restoration potential is as the area of land in million hectares that could be restored. We based this on the Baston et al. Data set, or this is the open source data set underlying the Crowther Labs Restore platform. But we did go one step further and we excluded boreal biomes. So boreal, taiga, tundra, and ice and rock biomes, because reforestation in those areas could potentially be harmful or very difficult, and most ecologists agree that essentially they should be left alone and protected. But we did include the rest of the data set, even though not necessarily all areas should be restored as forests, because seed banks can actually support restoration of nearly any ecosystem. So again, in this map, we've got the darker colors representing the higher amount of restoration potential in area. And of course, larger countries, again, have more restoration potential. And that includes the US, which actually has the most million hectares of restoration potential on a country basis. But again, that's very tightly tied to just the area available in general in the country. But it is good to note that these large countries do have a large area of restoration potential. But at the same time, we want to also notice that a lot of the countries in sub-Saharan Africa and Latin America uh, have high restoration potential per capita. So even some of the very small countries still have quite a lot of restoration potential area. Okay, so this is a slightly complicated slide. I'm going to walk you through it. So our next step was the most complicated step, was to put those last two factors together somehow. And we wanted to essentially estimate how much area of restoration could one seed bank support. And as you can probably imagine, this was not at all a straightforward task. The data don't exist to provide any kind of concrete answer, and what data we do have is highly variable. So we took the approach of calculating our answers using a range of scenarios. And just, yeah, absolutely acknowledging that a lot of assumptions, a lot of estimations go into this to give a somewhat realistic estimate of the amount of area that one seed bank could support. We first estimated the average capacity of a small restoration seed bank over 10 years of restoration. So with the idea that we have about 10 years to reforest the earth to make a real difference on climate change. And so we're going to attempt to meet this restoration potential in the next decade. So thinking about how much one seed bank could, how much capacity one seed bank could have over that 10-year period, we use sort of an average size small seed bank that might have about 3 refrigerators or freezers with an internal capacity of about 46 cubic feet or 1,300 liters. So this is a fairly small facility, but even with that, we made a calculation to estimate how many seeds it could hold on an annual basis or at any given time, um, using 5 different size classes of seeds and then kind of dividing those among the capacity. And then we estimated that about 2/3 of the capacity of the seed bank would be cycled through each year in support of restoration. So as seeds are withdrawn and used in restoration projects. And then we kind of set aside 1/3 of the capacity for the longer term storage, for the emergency response, those kinds of things. So using all those all those factors over 10 years, a small seed bank of this size, a restoration seed bank, could provide about 53.3 million seeds for restoration over that 10-year period. And then in this table shown here, we wanted to estimate the number of seeds needed per hectare under different need for seed scenarios. So if we first look at the arrows over here on the left side, the idea is that as planting density increases, the need for seeds would increase in quantity as well. So lower planting density, lower need for seeds, higher planting density, higher need for seeds. On the contrary, if germination rate or survival rate increase and go up, then your need for seeds actually decreases. So the quantity of seeds you need is less if you're having better germination and better survival of your plants in the field. And again, all of the data on these are pretty sparse. You know, there was no statistical analysis we could do with the very limited data out there, but we just made an estimate using these 3 factors of the ranges that might occur from this low to medium to high need for seed scenarios. And okay, and then if we look at the table, Depending on the need for seed scenario, one seed bank could support between 2,000 to about 22,000 hectares of restoration potential, or between 5,000 to about 54,000 acres of restoration. And then if we look at it kind of in a slightly different way, transferring it and looking at it in a different way, the number of seed banks that we would need per million hectare would be between 46 and 450 seed banks. So this was an interesting finding so that we could kind of get an idea of like what sort of area could one seed bank cover? How many seed banks do you need for your project, or how many projects might be able to share a seed bank? And we did use this average kind of small restoration seed bank, and we absolutely recognize that seed banks are going to vary in size. Some will be larger, some will be smaller, but we kind of use this as an average to estimate the need using a whole lot of different data that's all really variable and not very well defined. So based on that, we were able to put the other two data sets together, the existing seed banks and the restoration potential, into this map here to determine how many seed banks are still needed if we want to fulfill that global restoration potential within about 10 years. And essentially, we found that nearly all countries still need more seed banks. Interestingly, we can see that the US, despite already having the most seed banks, still needs the most seed banks in terms of overall quantities, from thousands to 10,000 of these small restoration seed banks. So that's interesting because we already, we have a lot of seed banking happening where there's a lot of strong, uh, seed supply chains in the US, but there still could be quite a need if we were to truly fulfill our restoration potential. And looking beyond that, we also see that the need for seed banks is also driven primarily by country size, with the US being one of the large countries, and then also with Australia and China and Brazil being the countries that need the most seed banks, based pretty much on their country size. Um, since most decision making happens at the country level, we wanted to kind of highlight this need at the country level. But I still want to call your attention again to sub-Saharan Africa and Latin America, where hundreds or thousands of seed banks are still needed to actually meet this global restoration potential, and where we know there are very few seed banks to begin with. Okay, and then with that in mind, one last thing to bring up is that one thing our study did not yet account for is restoration priority. So many of you may be familiar with this Strasberg et al. Study where they did a global assessment of priority areas for restoration based on biodiversity, climate change mitigation, and minimizing costs. And not surprisingly, the highest priority areas identified are mostly in the tropics and subtropics. So even though we need fewer seed banks in those regions, each each individual seed bank could have a really high impact on restoration outcomes. And even if we were to start by just adding a few more seed banks in these regions, that could double, triple our seed banking capacity and make a really big difference towards meeting these long-term goals. So to kind of sum up the seed bank benefits section, there's lots of really great benefits of seed banks that I think many of you may be familiar with, but to keep some of these other things in mind that we don't always think about relating to seed banks, some of the benefits include resilient communities, so empowering local seed sovereignty and keeping some seeds closer to home for some of the smaller communities. Cost effectiveness, which would include avoiding that seed waste that can really be very costly. Preventing delays, so like we were talking about earlier, allowing for continuous germination and planting even in those poor harvest years. Higher quality seeds, so since seed banks allow seeds to be tested, viability can also be preserved for longer periods of time. And then the seeds will also be more locally appropriate and well adapted to the location. We can, of course, increase biodiversity for healthy ecosystems. and provide business opportunities for local projects and communities as well. Seed banks can also contribute directly or indirectly to numerous sustainable development goals, providing many benefits to nature, including people and human communities as well. And in short, seed supply is the key. We must address this bottleneck to enable rapid scaling of projects, restore biodiversity, and enhance ecosystem resilience. And with that, I will hand it back over to Emily to talk a little bit about some of our solutions.
Thanks, Marian. So interesting. Yes, so like I said at the beginning, we employ reliable forestry methods that utilize technology in order to scale. Like, next slide. A range of seed bank options. So we're moving toward a more cost-effective model that can still be replicated at scale. We want to meet our partners where they are to get more people actively seed banking for the future, no matter their capacity. Therefore, we offer a range of products from do-it-yourself to containerized versions in regions where we have manufacturing sites. So each Terraformation seed bank is capable of storing up to 10 million native seeds. They can be supported with renewable energy if you choose, and they provide everything that you would need to start seed banking today. Plus, we also offer software and education. I'll get to that a little bit later. Next. We also offer tree nursery products of various sizes, depending on the organization's capacity. So our nurseries can produce high quality plants used in restoration projects, anywhere from 30 to 40,000 plants needed per year, all the way up to 100,000 plants per year. And our sidewalls are 6 feet tall to save workers' backs. Next. And when you combine the seed bank with the tree nursery, you never have to experience gaps in propagation due to a bad seed crop year, like Marian was just explaining. And therefore, you never have to compromise on biodiversity. So seed banks really de-risk a project from changing weather conditions, from being at the mercy of the market, like low viability rates or poor seedling to site matching, and all the things that come from not having control over your supply chain. Next. So Terraformation also provides training for its partners. There are 3 courses available now, actually, on seed collection, seed banking, and nursery management. So the seed courses have 7 videos each, and they star our lovely Dr. Marian Chau. And they're for people just starting out, so they're very beginner level. And they each have 7 videos with a quiz at the end to ensure retainment. And the nursery management course is a bit more advanced. It's more like best practices for an intermediate level of knowledge. And there's even a final exam at the end of the courses. So you get a certificate of completion once you've passed. Next. And finally, we offer software. We call it Terraware to manage the important data that's associated with seed collection and seed banking. So we have a seed bank database available to download now and test. And we're releasing an integrated mobile app with offline capabilities sometime this quarter. A tree planting app is also in development to assist with monitoring, and that will be extremely helpful for our partners. Because, knowledge is power, right? When you know exactly how many of each species you have, you're empowered to make data-informed decisions, and you can plan workflows more effectively. I mean, overall, Terraformation products, and support make a project more attractive and investable by improving supply chains and an organization's resilience in terms of operating efficiency. And now we get to hear about some of those partner success stories from Dr. Marian. Take it away.
Thank you again, Emily. So while many of our partnerships are still in early or initial stages of the restoration project, we already have some exciting numbers to share. And we just wanted to share a few stories that talk about how we've kind of integrated training and technology to achieve these goals. So this is a quick snapshot of where our partnerships are right now. So we have 9 containerized seed banks established. So they're in Hawaii, Ecuador, and several countries in East Africa. Across all of our different forestry projects, 375,000 plants have been planted and tracked. And of those, 227 different species have been planted. And so we're really proud of that number because it highlights the high biodiversity across these projects. And with the understanding that several of the projects are even in similar regions that do have overlap in their species. We do have 10 active countries, so that includes our seed bank projects and a number of other forestry projects that are supported either by other seed banks or have alternate seed sourcing in place. And I was so fortunate to travel to East Africa earlier this summer and visit some partner projects in Tanzania, Uganda, and Kenya, as well as co-hosting a tree seed workshop in Nairobi, and wanted to just share a few highlights from that trip. This is the fun part of the presentation. So one of our strong seed bank partners is this wonderful group called Saving Africa's Nature, or SANA. They are an NGO in Tanzania working to simultaneously restore ecosystems, wildlife corridors, and human communities. So several of the people you see pictured here are indigenous members of the local community who work with SANA in their restoration projects, as well as in the local community where they do other work to support things like human health and empowerment uh, and economic empowerment as well. This year, they have planted 33,500 plants, and they've had a 72% survival rate, which is very impressive because they've been suffering from a 2-year drought, ongoing 2-year drought. So it's a very challenging site for so many reasons, but I saw firsthand the care they took in the field to maximize survival using a lot of different creative methods, and I was really impressed with their dedication. They also have a new seed bank. It's not even fully outfitted yet with all its equipment because of supply chain challenges, but even so, they've already adapted it and have started banking over 200,000 seeds using some of the more basic methods, and they do at least have their fridges set up. So it was really exciting to see the seed bank in action and to see how excited everyone was about it and what it could provide for their project. Another big highlight of my trip, so getting a little bit more into some of the kind of partner and training insight. Um, so Benson is the seed bank manager at Sana in Tanzania, and he accompanied me to Uganda to visit another partner on the way to Nairobi. And this was a wonderful experience for everyone. Environmental Defenders is the group in Uganda. They're another NGO, and they work on restoring land and protecting human rights in the very remote Albertine Rift region of Uganda. Benson was thrilled to join me so that he could go and see their fully stocked seed bank and receive additional training there. But I was really excited for Benson to join me so that the two organizations could share knowledge and become collaborators and that we could all work together. Benson is conveniently wearing the bright blue shirt, so you can see him easily in action in all of the photos. There was a lot of different insights that I gained from just kind of watching how he interacted with this other group. There was one interesting story to come out of this, going into my lessons learned. There was one conversation that Benson and I had with an ED field staff member where they were feeling discouraged by, that they have all these native plants that they've planted, but they're in that 2-year drought. They're struggling. They're losing plants. They really wanted to plant a non-native species because they saw how it grew so much better than the native species. They were like, even around the nursery, it's just coming up. And so Benson and I had to kind of carefully explain that, these kinds of species can often become invasive and, explain why that's actually a lot worse for the ecosystem in the long run. Um, and so we had a good conversation around that. But I say that this lesson learned local context gives confidence because I'm not sure if hearing that explanation just from me, a global North foreigner, would have really been as convincing as hearing it from Benson, who works under similar East Africa contexts and understands some of the challenges they go through and still, gives it the weight that it deserves. So I was really glad to have him there for that discussion. And then Benson also ended up being the one who showed the environmental defenders team how to use our Terraformation's GIS mapping devices to track trees. He also walked them through the Terraware seed bank database that Emily was just mentioning, and he was absolutely happy to jump in and do that. And so I say that experience illustrates benefits, um, because he was able to tell them, not only walk them through it, but tell them exactly why he used different features or different fields even, and how each of these different steps can make his work easier, more efficient. Um, And he would give specific examples of how, oh, this is useful because of this situation in the field, and we love it, you know. And so I say enthusiasm is contagious, because Benson was so excited about what that technology could do that it really, you know, the team saw his excitement, and they were inspired by that, you know, to listen and learn and try to start using this technology more. Whereas before it was, you know, maybe felt like somewhat of a barrier because it was something to learn, it was another thing to do. I think that Benson's interaction with them was able to show, like, no, this is actually a way that can improve our processes and you know, lead to less stress and work in the long run. So all of that was just a really wonderful experience. And now I know that they've all been in touch with each other. Environmental Defenders is texting Benson for plant IDs and help with different things. So I'm really glad to see that they've connected, and they're now like sister organizations in restoration. Okay. Next on the agenda was the Tree Diversity and Quality Tree Seed Workshop for East Africa. This was held in Nairobi, and Terraformation co-sponsored it along with the World Agroforestry and Botanic Gardens Conservation International. It was a really lovely collaboration with those organizations, and it was also really well attended. This was a in-person gathering, and we had over 90 participants from NGOs, governments, and private sector from multiple countries, from both restoration focused and fully agriculture focused groups, and a lot of people in between. And it was just a really inspiringly diverse group of people that all came together to try to work together. And the first day of the workshop included presentations from different local and global perspectives. And then we also had group work where we had smaller group discussions, answering questions about like what we plant now and why, and how can we improve our practices, what's needed in East Africa. And then the second and third days focused on practical training for the participants. So it included, you know, a few presentations, giving theory and background, and then also a field trip out into the nearby forest to do some seed collection, visits to the World Agroforestry Gene Bank, Seed Bank, nurseries, all the different aspects. And people just absolutely loved that part. They loved being able to learn from a lot of these local experts. And then at the very end of the workshop, we followed up with more of that group discussion work to see kind of where we landed by the end of the workshop. And so some of the key insights that we came up with were that most of the organizations there, regardless of what they do, were planting some mixture of native and exotic species, tree species especially, but they all recognize the need for biodiversity. Even the ones who couldn't do much of it at all, they recognize that need. Um, Generally, it was found that East Africa seems to be at sort of an awareness level stage where they understand the need for biodiversity, but they're still struggling and still striving for the implementation stage. But that this seemed to be like a, you know, a catalyst for working towards that implementation. A huge insight that we've also found at Terraformation through some of our research is that if we're going to invest in biodiversity, it must support community livelihoods. So they can't do restoration work if they can't feed their children. Their communities need economic opportunities. And across the board, there was also this huge desire to improve seed quality overall, and an interest in seed banks to improve over the methods that they're currently using. And then finally, here are a couple of quotes from participants in the workshop that really inspired us to keep the momentum going for this region. I could also imagine this kind of workshop or a workshop series along these lines being very useful in other regions of the world as well. And would love to potentially collaborate with Forest Service on things like that. And with that, we will say thank you so much for your attention and for inviting us to be a part of this. Emily and I are available by email, and Christian will be available to answer questions after this. Emily, did you want to say anything else?
Mahalo nui loa. We look forward to working with you more closely.